This is Fan of Astronomy, episode number 10.
10, 9, ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Welcome all to another episode of Fan of Astronomy. I'm one of the hosts of this show, coming from beautiful Pittsburgh, Pennsylvania in the United States. My name is Angelo, and I'm joined from Sweden?
From the small town of Söderhamn in the north of Sweden. I'm Dan.
He is Don Horning.
Yeah, Dan.
Yeah, we're all going to call him Dan.
Like Dan.
Yeah, we're all going to call him Dan, but, you know, I try at least at the beginning of the show to pronounce your name right.
Yeah, it's you are almost correct in the pronunciation. But, yeah, let's go with Dan.
Okay, sounds good. Where did I mess up? The last name.
Okay, you'll never get that right.
Horning. What? Horning.
Yeah, pretty good.
Okay, Don Horning. Okay, got it.
Yes.
I can pronounce names. Come on, man.
Good. Asteroids.
Yes, we're going to talk about the big asteroids today, and it's going to be super exciting. But first, we have to talk about Patreon.
Yes, we do. Patreon is a way for you to fund this podcast and to sponsor it if you like it. And it's kind of like a contract. You say, I'll give you $2 if you make an episode. And we have to make actual episodes for you to pay us the money. And if we hit certain levels, we do stuff. If we hit $700, we will go weekly and produce an episode every week.
I would love to stop at $699. I'm just saying.
Well, when the train gets close to 700, it doesn't stop. We will also do bonus episodes along the way. And the first one is at $100 called Space Wants to Kill You.
Everything in space, in fact, wants you dead. The fact that we exist is not the norm. It is the absolute opposite. We should not be.
It's a miracle.
Here. Yeah. We should not be here. Like, it defies logic that intelligent life ever formed.
Sure does.
Yeah, I mean, so many things have to go right, and then on top of that, you have to still dodge so many literal bullets to stay alive that it's baffling, because everything wants you dead. Like, literally. Just stupid. So today we're going to talk about the Big Five. For those who listened last week, you know that we talked about the asteroid belt in general, but we have 5 huge ones that we need to talk about, and these 5 are called Ceres, Vesta, Pallas, Hygeia, and
Interamnia.
Look, I'm going to mess that up the entire time.
Yes.
Interamnia is how I came to be happy with pronouncing it.
Okay. Let's, well, it doesn't sound like the other ones, so that will work.
Okay, so this episode will give each of the big 5 objects in the main belt its rightly deserved time to shine. As we go over Ceres, Vesta, Pallas, Hygeia, and Interamnia, we would hope to bring these worlds into view just a little bit better. These 5 take up more than 50% of the entire belt's material. However, combined, the entire belt is still smaller than our own moon. It could be said that if you take these 5 away, we wouldn't even call it a belt. Without them, we would easily just look at it as, hey, there's a rock over there. Hey, a couple more over there. These giants bring it all together and make us view it as something worthy of real study with its own designation. Obviously, we're going to start with the big one. The first dwarf planet in our solar system, located at an average of 2.766 AUs from the sun, and is the only one, in fact, within Neptune's orbit. On New Year's Day 1801, Giuseppe Piazza looked up and finally discovered the predicted body between Mars and Jupiter and named it a planet. It remained the 5th planet until the 1850s, when it was reclassified as an asteroid. So Ceres, we're looking at what? It's a C-type, but a G-type asteroid.
Yeah, it's its own type, pretty much. It was counted as a C-type, but now it's Ceres. It's special in every way, and you will have to pull me off it in order to stop talking about it.
Okay, so that in the Thalen scale, it's a G class, but more importantly, it's a dwarf planet.
Yes, it's a dwarf planet. It's rounded by its own gravity, and it's made out of ice and rock, so rounding it is pretty difficult. You could find smaller things in the Kuiper belt made mostly of ice that is rounded, that are smaller. But this is in a way, the lower limit for a dwarf planet. It's really tiny compared to the other acknowledged dwarf planets in our solar system. But if you look at the stuff that should be dwarf planets, you find only 3 things bigger than Ceres. And that's my favorite 2007 OR10, Quar, and Sedna. And then you have 2 other objects of similar size to Ceres, but Ceres is slightly bigger than Orcus and 2002 MS4. A dwarf planet this close to the Earth is interesting, of course, because the other ones are far out, like Pluto and Eris, and out there, past Neptune.
Yeah.
Here it is. A dwarf planet close to us. It is also an asteroid. We should not forget that. It's the number 1 asteroid, the first one discovered, the biggest one. It's 33% of the mass of the asteroid belt in just one thing. When Dawn went to Ceres, Dawn is still going on, but it was a super interesting mission 2 years ago. It orbited Vesta for a while, and then it went to Ceres, and is now orbiting Ceres. We learned so much about this place, because we learned so much about Pluto in 2015, but New Horizons just blitzed past Pluto, and Dawn is still orbiting, so we're still getting a lot of data. It seems that we know now that Ceres has a rocky core and an icy mantle, and it is very likely that we have an internal ocean of liquid water. And the estimates right now is that this internal ocean has more water than all fresh water on Earth. Yeah. Which is pretty interesting.
Fresh water. That has to be stressed, not water, fresh water.
Fresh water, yes. This means that Ceres is now one likely candidate for life in the solar system, which was considered a bizarre statement in 2014.
Yeah, and we get a lot of our evidence for, this underground ocean, basically from cryovolcanism. That's basically volcanoes made of ice that shoot water up into space, and the biggest one is named Ahana Mons, and it's just one of many.
Now, it looks like it's kind of the only one that's active right now. As well, we can see traces of other ice volcanoes. But this one has recent activity.
Right. And I mean, this thing is 4 kilometers big, or 4 kilometers high, and we're talking about 4 kilometers high on a planet, dwarf planet, whatever you want to call it, with a mean radius of only 473 kilometers. So this thing sticks up.
This is like the size of the highest Alps.
Yeah.
In Europe, and it's on this tiny dwarf planet. So it's quite an impressive mountain.
It's like having a nose. Just bang, there it is. The planet has a nose.
Well, I'm just speechless thinking about this crazy place.
It's nuts. I mean, it's riddled with these bright spots, too.
Yes, and it looks like there are still debate going on what they are.
Right.
But they're probably salts.
Right, but it's a special type of salt. It's not they think. It could be normal salt, that we know, what is that, nitrogen carbonate?
Yeah.
Or sulfate, yeah. Well, this one is nitrogen carbonate salt is what they believe this is. But they have no, factual evidence. It's not like they've sent something down there to actually pick up the chemical composition of it. And as we've learned with comets, that you can think that it's one thing, and then when you actually get the chemical composition, it's completely different. Like, we thought that we was going to find water, like normal water, on that one comet that we dropped the dishwasher on, and it turned out that it wasn't normal water. It was a different type of water, but still water.
Yes.
So, I mean, but that's what they currently think.
Yeah. It's, there are discussion about it, but, some sort of salt and, maybe mixed with ice. Turns out that, Ceres is close to the sun compared to a lot of things in the solar system. So its temperature is about 230 Kelvin. And this is far below freezing, but not too far. So ice itself is kind of behaving like in winter on Earth. Really, really tough Siberian winter, but you still get ice behaving not like rock, but like a body in a way. So the ice on Ceres could move and do things like that, whereas the ice on Pluto, it's just frozen solid. Which means that strange things happen on Ceres.
Such as? Talk to me. You said I'm going to have to literally pull you off of the talking about Ceres. So the way I'm looking at it is the next 10 minutes or so, I shouldn't have to talk.
Okay. We have a period, about 4.6 Earth years. Ceres hangs around at about 2.7 AU, which is pretty in the middle of the asteroid belt. The radius of Ceres is 470 kilometers. I will post pictures of the 5 big asteroids superimposed over Earth countries, so you get a pretty good picture of how big they are. The total surface area is about the same as India or Argentina on Ceres. So it's both small and big at the same time, depending on what scale you look at it. If you look at it next to the moon or Pluto, it's really small. But if you look at it next to Belgium, it's enormous.
Yeah, I mean, if you think of it on a person scale, like you can fit a lot of people in Argentina.
Oh, yes.
So that's big. But yeah, if you look at it on a cosmic scale, I mean, we're tiny. So that makes this thing minuscule.
Yes.
So it's all on what scale you want to look at it.
If you look at the stuff that's in the solar system, which we will come back to, size-wise, which we will come back to in our news item, it's the 33rd biggest object in the solar system. And that's pretty big.
Spoiler alert, Dan.
Yeah?
Yeah, you let them know that the news section is coming back for this episode. Wow, dude.
Yes.
Just spoiling everything.
Listening. We have a small actual tilt on Ceres, which creates poles. So you have areas at the poles which are in constant darkness, which creates sort of an ice trap. So if you have water vapor in the atmosphere, if you could call it an atmosphere, which Ceres has, we discover water emissions from Ceres.
Yeah, it's a tenuous atmosphere at best.
Yeah,
I mean,
of course
it's just water vapor left from, Ahana Mons mostly. It's just still kind of hovering around. The gravity's kind of keeping it in place, but it does have a loose atmosphere.
Yes, we do. We also, if you have super good eye vision, you're sharp-sighted and you're in a totally dark environment, you can see Ceres.
Yep. Or if you have a pair of binoculars.
Yes. And it's not a coincidence that it was the first asteroid discovered and they thought it was a planet because it's pretty easy to spot compared to the other ones.
Yeah, I mean, like, when I say binoculars, I mean binoculars. Like, you don't need a telescope to see Ceres. Just go grab your binoculars, look out like you would, instead of looking at your neighbor's wife, turn your binoculars into the sky and you will see this dwarf planet if you look at the right area during the right time and all that other stuff. But you can actually just see them with normal binoculars. You don't need anything crazy.
Yes.
Did I throw you off when I said turn it away from your neighbor's wife?
Yes.
Well, I'm sorry. I have to bring some humor to this. It can't be all just fact. I mean, at some point we got to make people laugh.
I was looking for my neighbor's wife in the window, but she wasn't up.
Oh, darn. That's okay. They look best as soon as they're pulling out of bed. Oh, wait, I shouldn't talk like that.
Happen my wife doesn't listen to this podcast.
Neither does mine. She makes it a point to go to bed before I start, and she never downloads it.
So one thing that confused me was, okay, if we have a liquid water ocean under an ice shell on Ceres, what keeps the water liquid?
Friction.
You should have some sort of heat source, right?
I would say friction.
It's, what kind of friction?
I don't know exactly what type, but I would think that Jupiter's pulling on it a little bit. And just like the gravitational forces of everything that's around it probably pulls, in multiple different directions, which causes ice flows to shift ever so slightly like tides. And that's going to create friction, and that friction will create liquid. And, this creates the volcanoes because, as any early physics exam will teach you, when it goes from a solid to a liquid, it gets bigger. It takes up more space. Yes, it takes up more space.
The pressure from the ice sheet will help. But there seems to be a source of heat on this tiny dwarf planet as well. And it's probably radioactive.
Ooh.
So, in a sense, this is not a dead rock like we thought it was. But there's something going on inside of it.
There's a star in the middle of it.
No, probably not.
Oh, darn.
Ceres is pretty much a protoplanet. This was a planet that was supposed to form, but Jupiter messed it up. So all of that stuff that we talked about last time that was lost from the main belt, that could have gone here and created a nice, maybe even Mars-sized planet? Mercury-sized planet at least?
Maybe bigger. We don't know. We don't know what was in the belt that long ago.
Jupiter destroyed it. Jupiter wrecked it. So we get this dwarf planet, but we still get this dwarf planet, which is super interesting. We think about Europa as the main source for our hope for life in the solar system is like the number one candidate. But conditions here are somewhat similar and much closer to the sun, which means heat. We don't have the great heat source of Jupiter gravity.
Right.
But we do have the sun, which is a much better heat.
We do.
So we do have to look at this place a lot more to learn more. And there is some crazy Chinese space plan for this. The Chinese Space Agency is going to do a sample retrieval mission.
Ooh, we're going to find out what that salt is.
That will land on Ceres in the 2020s.
That's awesome.
Well, that will be so amazing.
And you know why they're doing this, right?
You have to get there first.
No, because it got promoted from an asteroid to a dwarf planet. To say it happened in 2006, it's weird because Ceres, like the Dawn mission and New Horizons, yes. So the Dawn mission and New Horizons were like a month apart. Okay, so like the Ceres stuff came in and everyone's like, ooh, and then a month later the Pluto stuff comes in and it kind of shuts everything up. But if it wasn't for Pluto getting demoted, Ceres would have still been just considered a normal asteroid and never would have became a dwarf planet. So like these two will forever be linked. And it's not just from the missions. It's from just in general. It seems like the two seem to have things happen at the same time, at least as of late.
Yes. Yeah. Some other stuff. It rotates in 9 hours around itself. So,
it does.
Ceres day is 9.1 hours.
Yes.
We have some, yeah.
I was going to say, like, we keep calling it Ceres, but if you're, from Greece per se, they call it, Demeter. And that's not to be confused with 1108 Demeter, which is another asteroid, but they call it Demeter. And for a while in Greece or in Germany, this was called Hera.
That's weird.
Yeah, I thought that was a little strange too, but
that should be something around Jupiter.
It really should be, realistically, but they used to. Now they kind of go with the international Ceres way of saying it, and I think that's kind of neat. The fact that it's called something different elsewhere, and we've had rare earth elements were actually named after this thing, cerium.
Yeah, it was. So whenever you use cerium, think about Ceres. But there will be a lot more data coming out of Dawn and other things looking at Ceres. So stay tuned for that.
I mean, this is easily it's weird because when Pluto was being visited by New Horizon, I was still soaking up all the info from, the initial Dawn thing. And I had already kind of had a love affair with this place because, it was our fifth planet. Like, why did it get demoted? Why, I spent a lot more time than most people normally do actually looking into this place. And I mean, you've covered it fairly well. But I love this place and I just wanted to make sure everybody understands that.
It also raises the question that if we learned this much from visiting Ceres, we learned that much from going past Pluto, which secrets do the other dwarf planets hide? So New Horizons couldn't make it to another dwarf planet after Pluto, but I think that a mission to Eris would be really interesting. I think that's the prime target as well.
See, I want them to send one to Maki Maki.
Or Haumea.
No, specifically Maki Maki, because it's so weird shaped. Like, I just want them to send it there. Like, I want to get close-ups of that. That's the next place on my personal hit list that I want to see.
Yeah, random fact that could be interesting as well is that the so-called moon, but rather the sister dwarf planet of Pluto, Charon, it's actually bigger than Ceres is.
Charon is bigger?
Yeah, Charon is 600 kilometers diameter. So it's much bigger. And if you look at the mass, it's about 30% bigger. Oh, no, I'm talking in my, let me get that right. It's bigger volume-wise and mass-wise, it's about 60% bigger than Ceres.
Okay. Makes sense.
Of course, Charon, rounded by its own gravity, it's the shared gravitational center between Pluto and Charon is way outside of Pluto. Charon is a dwarf planet.
Is it?
Yes, but now I left the subject. I think I'm done with Ceres for the time being. Do you have anything to
You pretty much covered everything that I would have covered about it. I mean, you failed to mention that, you did say that it has a rocky core and an icy mantle, but the crust is mostly carbonate and clay. So it's actually kind of close to what you'd find in a lot of regions of the United States and of the world, I would assume.
How did that happen?
I have no freaking clue. It
has taken a lot of hits of stuff, so maybe that's remains so, crap that landed.
Well, the thing is, you're talking, well, how does, clays form? Well, I mean, how did we get clay? You know what I mean? It's one of those things where it's like, oh, I don't freaking know. I'm not an astronomer. I just play one on the radio.
One more thing.
Definitely not a geologist, so meh.
One more thing about Ceres. We used to think that it was part of collisional family. We like to arrange these asteroids into collisional families. They were once the same object. But now we know the Ceres is so different. So this collisional family was demoted to being named after some much smaller asteroid that was the second biggest in the family. And Ceres is not part of it. But Vesta is part of one collisional family.
Vesta. So, now we move to Vesta, a giant asteroid located just 2.362 AUs from the sun. Heinrich Wilhelm Olbers found it on March 28, 1807. It was the fourth item found inside the asteroid belt. Strangely, it was the fourth discovered, yet it's clearly the brightest of the asteroids from Earth. Named after the Roman goddess of hearth and home, number 4 Vesta is where we turn our attention to now. So Vesta is a V class because it, like everything in that collision, they just call V after Vesta. But it's named Hestia in Greece because they can't keep any of the same names that we keep. And it's named Zhaoxingji in China, which translates to Hearth God Star. This was initially classified as a planet, same as Ceres, and it suffered basically the same fate as being demoted in the 1850. Coup. Oh, after Vesta was discovered, though, there was a 38-year gap between that one and the next one that they found. So there was just like so much time. Like at first it was like, asteroid. They discovered these, 4 asteroids really quickly. And then there was 38 years before they found another one. So that's part of the reason why at first they was like, oh, that's a planet. Oh, that's a planet. Oh, that's a planet. Hey, you get a planet and you get a planet and you get a planet, like Oprah. And then after 38 years, they're like, wait. We found a bunch more crap up there. Those all can't be planets. And they demoted them all. And that happened in the 1850s.
I want to give a short thought to 3 Juno. That is not part of our podcast today. It was the 3rd asteroid discovered. We used to think it was really big, but it falls outside the top 5 now.
It does, sadly.
Cheers for Juno.
Yeah, Vesta will orbit the sun in exactly 3.6 Earth years.
Oh, that's fast.
Yeah, it is fairly fast. Decameter-sized object was detected by dawn, so it's believed to have a quasi-satellite, not a proper one. They don't think that this thing is completely locked in, so it doesn't have a moon. Its 4 rotations takes 5.342 hours.
Wow, that's fast.
So that's how long their days are. Zip, meow. 5 hours later, new day. It's the second largest asteroid, yet it is only a quarter of the size of Ceres. The surface area total, 800,000 square kilometers, is about the size of Pakistan.
Yes, it's the 65th biggest object in the solar system, so that's quite a difference from 33rd place for Ceres.
Yeah, it's not quite round. It's close. It's an oblate spheroid. Think of you having like a rubber bouncy ball and you stick your foot on it. You know how it kind of smushes down? That's what this looks like. There are some major craters on it. The biggest of this is Ray Sylvia. Yes, and that's on the South Pole. The width is 95% the mean diameter of Vesta. So like this was a huge hit.
Yikes.
This almost destroyed this thing completely. This was a huge hit. The hit landed 19 kilometers deep.
Yikes.
And in fact, this collision is believed to have caused all the V-type asteroids that we currently talk about. About 1% of Vesta was lost during that strike. And Ray Sylvia is so big that there's a crater that it overlays called the Venini crater. Words and stuff. I'm good at this.
Venenea.
The Venenea crater. And we know of this impact because we found rocks from it here on Earth.
That's so fantastic.
Yeah, and it has these neat troughs. And when I say troughs, I mean like when you look at it, it almost looks rippled in a way. And some of these gaps in these troughs are, they dwarf the Grand Canyon by a lot.
Wow.
Yeah, I mean, these things go deep when you really think about it. It's like, oh, well, we're on this big, kind of rock, and holy crap, this trough really runs deep. And it's like, think rolling hills, but as deep as the Grand Canyon or more, and then it comes back up into another rolling hill. And it's like that well over the planet. I'm sorry, it's not a planet. It is an asteroid. As of now, we'll get to that later.
Yes.
The crust is mainly eucrates, diogenites, and regolith, which we've talked to before. And this is also a visible to the naked eye object, but you got to be in an area without any light pollution. So you have to kind of go out in the middle of the nowhere, but you can spot it with, the naked eye.
Yeah.
Do you have anything you would like to add to number 4 Vesta?
Yeah, I'd like to add that as this is closer to us, closer to the sun, it's even warmer. So you can get on a good sunny day to about 250 Kelvin, which is like what we've had that temperature here this winter.
You can get a tan there.
Yeah, but if you're on the night side of Vesta, you are in trouble.
You can't get a tan there.
No, your tan would be pretty white.
Oh my, you'd look like one of those things from the new Mad Max movie.
Yes.
Those children look terrible. How did they get white?
This is so close to a round object that it was considered as a dwarf planet candidate, but now with Dawn's measurements and so we know that it's not round.
As of now.
Yeah, so it's a pretty interesting limit in the list of solar system objects by size. That we know that Vesta has a high density, so there could be an object of Vesta size in the Kuiper belt, for example, made of ice that could be round under its own gravity.
Yeah, absolutely. And then that would be considered a dwarf planet, where this is currently not because of the naming conventions. But it's not that far off from round that I wouldn't hold it against you for saying it's round enough.
It's very close to round enough.
So we've mentioned Dawn a couple times now. A lot of what we know of the Big Two is because of the Dawn mission. The pictures alone that were sent back are worth spending an hour or two just observing. Without the Dawn mission, we wouldn't fully understand all the intricacies of Ceres and Vesta. If anything, it makes us hope that further observations on other asteroids are deemed important enough to send other crafts out. So Dawn was launched in 2007, and it did some things.
It did. I think it was the first mission that was a multi-target orbiter that could go into orbit around something, then leave it and go to another orbit. That's pretty amazing.
It also was the first exploratory mission to use ion propulsion.
Yeah, and that makes sense. If you think about it, New Horizons was launched before this.
Yes.
And they reached their targets at the same time, but the targets for Dawn were, of course, a lot closer. And this was a very, I think compared to New Horizons, very cheap mission because of the ion propulsion.
Uh-huh.
And I'd say it's a technology that could get us to places for a fraction of the cost, which is kind of interesting.
And at an increase in speed.
Yeah.
So, I mean, that's good. These are the big sales that we talked about a long time ago. I am fascinated by ion propulsion, so I had to bring.
Yeah, and compared to New Horizons' long life before it hit Pluto, it sort of, okay, it's passing by Jupiter, maybe it sees something, but not much was happening. But Dawn was a continuing story from, it reached Vesta on July 16th in 2011, and it hung around in orbit for 14 months. So I was following Dawn already back then, and then it's gonna get to Ceres. And it took off from Vesta, and everything worked. And it had a very close, a big problem right when it was about to go into orbit around Ceres. Of course, it hit some cosmic rays that it wasn't prepared for, so it had to enter Ceres orbit from a totally different direction than they planned it. But it worked. So it reached Ceres on March 6th in 2015 and had its 4 months of glory before New Horizons reached Pluto.
Yeah, but it's still there. It perpetually will just stay in orbit around Ceres, so I guess you could say Ceres has a moon. We just made it.
I don't know how long it will be able to stay in orbit, because of course it's not stable.
Yeah, I mean,
I think.
from all the reading I did, it's caught. And it's hit the right speed. It's just going to stay there. So
well, there is no other gravity well nearby, so it's not like trying to put something in orbit around the moon, because here you could have a stable orbit.
Yeah.
So it's probably there forever then.
Yeah, I mean, they say perpetually it's going to be stuck there. I mean, that's kind of cool.
I wonder how long we can keep in touch with it.
I honestly have no clue. I tried to look a little bit into it. I mean, it's still going on now. So I would think as long as they could power it up solarly, they should be able to, keep contact with it. But at some point, it's going to lose its useful.
Yeah. Did you understand how close it is to Ceres?
No, I did not.
No, I tried to find that, but it seems to be pretty far out, because that's the stable orbit.
Yeah.
But more data to come from Dawn.
And others.
Yes.
And others. So our, second discovered yet third largest asteroid is Pallas, discovered March 28th, 1802. This asteroid has been studied far less than our first. Olbers was a busy man, obviously, because he discovered this body not long before he discovered it. So what do you got to say about Pallas? Like, this is one that isn't it?
I think it is super boring compared to the other two, but
okay, I'll take it then. Jeez, I guess I can do it. Okay, so Pallas is a B-type asteroid. It is 2.773 AUs from the sun on average. It has its orbit is, it kind of good bit. It's 22% the size of, so I mean, we're getting into the ones that aren't as studied as much, so they are going to become a little bit boring, but this really isn't much smaller than Vesta.
Oh, they're very similar in size.
So, I mean, this one, if we send things to it, I'm sure it'll become a lot more. This thing makes up 7% of the entire asteroid belt. From time to time, Pallas has been considered throughout history, just, because our observations were a little bit off, that we thought it was the second largest. However, newer observation has placed it at third, better technology, it's better. We have Hubble pictures of this thing, but it shows very little surface. It's kind of weird. Like, the one thing that we did notice from it, though, is the light curve are extremely small in them. It means that as far as surface terrain, it doesn't seem like it has much of any craters, mountains, anything. Just kind of a perfect ball out there.
It really is.
Yeah. Like, I mean, there is obviously some light curve, but it's extremely small. Not exactly. This is almost like a perfect. It was a planet.
Wow, that's.
Go ahead.
That makes you wonder if there's some kind of activity on it.
Yeah, you would wonder, it's in the asteroid. You would think that this can't be the one thing in the asteroid never to get hit. I would think that would be naive. So it's like it has to have something going on that creates this thing to fill in its holes.
Yeah.
It's just odd. I would love to see and it almost was a part of the Dawn mission. They couldn't add this.
I think the reason for that is that Pallas hangs around at about the same distance from the sun as Ceres does.
Yes, it does. Very similar.
It seems to be that they have some sort of resonance relationship, but this is not possible because they are too small. But they are really coordinated.
Yeah, they're almost.
So there's absolutely no chance that they crash into each other.
No.
But it might be that Jupiter sorted them in sort of some order, but they look to be related almost.
You have to kind of think of them. They're on the exact same orbit track. They're a couple AU or a couple point AU. So,
yes, not a full AU.
Yeah, AU. I mean, they're a little bit separated. They're almost on the exact same orbital. So if one's here, the other one has to be way over there. Because if it's not, it will run the risk of crashing.
So like they hate each other.
Yeah, it's like one's on one side of the solar system while the other one's on the other side of the solar system orbit. They have to stay that way, because if not, then you run the risk of, problems.
Pallas is a lot wilder as well. It goes further out and it comes further in.
Yes.
But their average orbit is very similar.
Exact same, 4.6 years.
Yeah, that's very close.
I mean, it's the exact same, 4.6 year orbit. It's not perfectly round, so it's not considered a dwarf planet. And this is another one that if you wanted to consider it one, I mean, I wouldn't argue with it. The light curve alone from the Hubble pictures tells me that this thing's rounder than we seem to think. But it's just odd.
That should be stressed that we don't know, really.
Yeah, I mean,
if it's round.
The Hubble picture does not give us a good enough view of it to really say, oh, this is what it is. It just kind of is.
It really looks like a picture of Vesta.
Yeah.
I know. A bad picture of Vesta, like a picture from the 70s of Vesta.
Okay, so now we're going to move a little closer to Jupiter. We're going to go to Hygeia. The 10th discovered asteroid and the 4th biggest was found in 1849 by Gasparis. We have no real pictures up close of this one, and although the Hubble pictures kind of makes it look like a 20-sided dice, its heavily carbonated surface makes this thing extremely dark to us. This one's yours, dude. I took the last boring one.
The C-class asteroid. It makes up 2.9% of the mass of the asteroid belt.
So there's a major drop-off between the 3rd biggest and the 4th biggest.
Yeah, it's about then 1/3 of the mass of Vesta or Pallas. It hangs around at 3.139 AU on average. Very dim, very kind of dark. It's far away, really hard to see. Goes around the sun in 5.57 years. And it seems to rotate very slowly compared to the others. It takes more than 24 hours for a day on Hygeia. 27 hours and 37 minutes.
That's a long day.
That's definitely a long day.
We could use those days here.
The days of Hygeia.
Yeah, I mean, we could use those here, legitimately. Like, I mean, a 27-hour day would be just about perfect for me.
We know so little about Hygeia that we don't even know the diameter. It's somewhere between 350 and 500 kilometers.
Yeah, so that's a big range.
We kind of know the mass better, but still quite uncertain about that. So more needs to be discovered about this one.
It really does. I mean, and our next one as well, the last one, the 5th one. This is going to be an adventure personally for me. As I've demonstrated already in this episode, I have a hard time pronouncing this. Let's go with Interamnia. I hope I got that right. I've been practicing, but I probably still screwed it up. Anyway, Interamnia is our 5th largest asteroid. It's only recently been discovered as far as the big ones go, found in October 1910. It is the 704th asteroid that we found. Vincenzo Sorelli is the man who's credited with discovering it, and it is located at 3.067 AUs from our sun.
Yeah, look at these numbers. 1 Ceres, 4 Vesta, 2 Pallas, 10 Hygeia, 704 Interamnia. It was late.
Yeah, this thing is stupid dark, and it's super far away, and it's only, it makes up only 1.2% of the asteroid belt. So this is, less than half the size of Hygeia.
Yes, it's the biggest F-class asteroid. We think there is absolutely no water on it, making it extremely solid. So high density thing. Mm-hmm. 5.35 years to go around the sun. It's closer than Hygeia, but no, it's closer than something we talked about. It is closer than Hygeia.
Yes, it is. It's closer
by
like 0.1 AUs, a little
less.
less.
You think that's not much, but it's many kilometers closer. There's not much to say about it.
Yeah, I mean, it's something that we just have not been able to study because of its distance, its size, and its basic coloring. Like, I mean, we just can't see it yet. We're not going to truly know until we send the stuff there.
And of course, everything is uncertain here as well. We get estimates of the mass and the diameter, but it's still uncertain. The last figure is from 2014 for the mass, so that's pretty recent. We think it's 350 kilometers across diameter.
We think. But we don't know, and that's kind of makes it hard. We don't know the shape really of it. We believe that it would be roundish just because of the size, but we don't know.
No, and because of the density, it could be that it isn't.
Yeah, it could be completely, a flat disk for all we know. Well, it's probably not that, but.
And if you look at the pictures of these places, we have these great pictures of Vesta and Ceres, of course.
Yep.
But we still have pictures that clearly show that these things are rocks for the others. But for this one, it's just a dot.
Yeah. I was going to say, did you see a picture besides a dot? Because that's all I saw.
It's just a dot. It's like, oh, that thing is moving a lot faster than the stars. So if you look at the night sky, so it's an asteroid.
Yeah, it must be something. There's something there. So yeah, those are our big 5. I know that, we promised a whole show on the big 5, but some news came out, so we're going to talk about this news. And truthfully, Once you get past the first 2, there's really not as much to talk about as, we would hope, because of the fact that, we've actually sent crap to the first two.
Yeah, I'm so happy we did, because the knowledge we had about Ceres and Vesta in 2014 was really, really ridiculous compared to what we know now.
Oh, it was nominal. I mean, now you look at them and you see worlds.
Yes.
I mean, you legitimately look at them and go, oh, those are worlds. Where before we was just like, yeah, it's a rock. And we didn't really think nothing of it. And now it's like, holy crap, these things are, especially Ceres. Like, Ceres is alive.
Oh, yes.
And those two that it went to, absolutely.
No, I forgot the wildest thing about the Ceres life theory.
Oh, okay.
That, as you said, we found rocks from the collision on Vesta on Earth.
Yes.
So if you think about panspermia, the transfer of life between celestial objects or objects in space, it could actually be. Yeah, there is a non-zero chance that Earth life could have originated on Ceres. That's wild.
Okay.
Okay, continue.
And the Earth is flat.
No, it's much more likely than the Earth is flat.
It is much more likely, but it's not.
I said non-zero, so it's pretty close to zero, but
okay.
It's not zero.
Non-zero chance. All right, I'll go with your non-zero chance.
So I hope the Chinese, they will of course only get surface samples from Ceres, but what if we could drill through the ice?
I'm sure we could.
But we will drill through the ice on Europa first, I bet.
Maybe. I mean, who knows? It just takes one billionaire who's crazy enough to spend his money for us to go there first.
Yeah, hopefully a Chinese billionaire that already did it.
Okay, so we're going to take a real quick break, and we're going to return to talk about something that popped up in the news that I think we need to talk about. It's not something we can
yes,
ignore.
we do.
We'll be back in a moment.
Hello. Are you enjoying the show so far? I hope you are. Well, if so, I encourage you all to pause the show. Don't worry, we'll wait. Go to facebook.com/fan of astronomy and hit that like button. You'll be one of the first people to know when a new episode comes out. Also, on that page, the guys post articles on the latest news in the astronomy field and outer space in general. You also get to interact with the hosts of our show, Dan and Angelo, there, so please hit that like button on Facebook. Thanks.
Okay, so we're back to talk about news, which, we kind of kiboshed from the show a little bit, but we did say when something important comes up, we're going to absolutely need to talk about it. And this is something kind of important. A new proposal has been put forth to redefine the geophysical definition of a planet. Okay? You're hearing me on this.
Yes.
So
yep. Go ahead.
Why are they doing this? Belief is that non-planets cease to be worth exploration by governments. So funding is a major reason behind this new definition. And Dan, do you want to explain what the new proposed definition is?
Yes. And in order to do that, I think we have to discuss the old definition first, because planets were never defined until 2006 with the great Pluto debacle. And I get the feeling that one of the main things behind this proposal is that Pluto has to be a planet again, and this will make Pluto a planet.
Yeah, to us older people, we all grew up with Pluto as a planet. And the reason Pluto isn't a planet, the current definition states that, one, and this was put forward by the IAU, and the first part of it is, it must be round.
Yeah, it must be rounded by its own gravity.
Yeah, so alright, it must be a round object in space. That's cool. It also must orbit our star. It must orbit the sun. Okay.
Or a star.
No, the sun, specifically. That's why we have separate definitions for exoplanets.
Oh, okay.
And we have a separate definition for rogue planets. Because they do not fit the qualification put forward. It does not orbit the sun. So every planet that's out there is not a planet. It's an exoplanet. Very specifically, like, it doesn't cover it. Yeah. Or it's a rogue planet, but that's a completely different story. And it must have cleared out its area of orbit.
And that's a big problem with the definition, because clearing an orbit is of course much easier if you have a small orbit.
Right.
So if you're a giant planet orbiting at 700 AU, have you really cleared your orbit? If you're an Earth-sized planet orbiting at 1500 AU, which there could very well be one, it surely hasn't cleared its orbit.
No, I mean, if there's enough junk out there for it to be there, then its orbit is so big that there's still going to be junk there.
Yes, if you want to attack this 2006 definition, that's the point of attack, because that becomes a big problem.
I mean, it's flawed because it only recognizes planets around our sun and not exoplanets and rogue planets. Plus the zone clearing thing is just a time thing.
Yeah.
You know, like, oh, you give it enough time, it'll clear it. So why isn't it a planet before that? You know, it kind of makes no sense. It's like, well, so you're telling me in a million years that thing's going to get no bigger, or a billion years, it's going to get no bigger, but it's going to clear its orbit. It's just going to take that long. So that thing's not a planet? What?
So according to this definition, then, we get 8 or 9 planets, counting planet 9, which probably has cleared its orbit.
Planet 9 is not confirmed, so as of now, we have 8.
We have 9. But we'll get back to planet 9 when we get there. The new definition is the following. A planet is a substellar mass body that has never undergone nuclear fusion and has sufficient self-gravitation to assume a spheroidal shape adequately described by a triaxial ellipsoid regardless of its orbital parameters.
Okay, so let's break that down. When it says has never undergone nuclear fusion. So
it can't be a star.
That's all that says is it can't be a star. So
and that's specifically to exclude brown dwarfs that have gone dormant.
Right. Sufficient self-gravitation to assume a spherical shape adequately described by a triaxial ellipsoid. So round isn't round if it's on a triaxial ellipsoid.
Yeah, that'll make Maki round.
According to this definition, yeah. So you know the one I talked about earlier that, you know, what was that, Pallas? Where it's like a ball that somebody stuck their foot on, that would become round under this definition.
Oh, that's why they can get to 110.
Yes! So, I mean, under that definition, it really changes things. And the new definition would essentially create 110 known planets in our solar system, including our own moon.
Yes, because you can orbit a planet and still be a planet.
So we would be a 5-planetary system.
Yeah, and that makes it sound like this is a plan to go to the moon again, because then, of course, you would go to the moon again. Oh, it's a planet. We have to go to it.
Our 8 current planets are modified by the words terrestrial, which would be like us, giant, which, you know, is like Jupiter, and ice giant. Pluto? Nobody argues that a giant isn't a planet. So for the sake of just words alone, why isn't a dwarf a planet? And that's a pretty good argument. Just by saying that something is a dwarf planet, we don't think of it as a planet anymore. But all those other types are all planets. So because, you know, it's kind of weird in a perfect world of PC-ness that we live in today. You would think that, you know, just because it's smaller, it's still a planet. You know, it's just, I wouldn't walk up to a dwarf specifically and go, "You're not a person."
Oh,
you get what I'm saying? So it kind of falls in that same thing where it's like, this doesn't make no sense that dwarf planets aren't considered planets because, you know, think about it. Would you walk up to a little person and go, "You're not a person"?
Oh, let's not go there.
I mean, you wouldn't. I'd hope you wouldn't. And it just kind of is what it is. But 110 planets, Dan, we need to converse about this. We need to talk about, do we think this is a good idea? Do we like this proposal? What flaws do we see in this proposal? We have a lot to discuss here.
Yes, I think that moons are planets is my biggest problem with this.
See, I like that because when I look at the moon, and me and you kind of had this argument before when I said that, you know, looking from a distance, people would look in and see a biplanetary system. And I like that definition because when I look at the moon, I see a different world.
Yeah, and you would do that more if it was a planet.
Yeah, I mean, to me, when I talk about the moon, it's a different world. When I talk about, you know, some of the large Jupiter ones, that's a different world. And if I'm going to use the word world, I should be able to use the word planet. Dig?
I'm looking at the picture now of all the proposed planets,
but
it's so small, so I can't see which one the smallest one is. But there is a lot of rocks out there that will be planets. As I said, Vesta is number 65 in size for the solar system, so 45 more than Vesta. These are small things.
Here's one of the flaws that I find in this.
Okay.
When I went to school, I had to learn all 9 planets. Yeah, it became 8. Shut up. But I had to learn all 9 planets. Can you imagine going to school and having to learn all 110?
I saw this addressed somewhere that, no, you wouldn't have to learn 110 because they would talk about classical planets.
I guess, but I mean, it's the same.
Which include Pluto.
I mean, I guess, but at the same time, like, I had to learn the entire periodic table.
Oh, God.
Yeah.
I never had to do that.
I had to know that whole frickin' thing by the time I got out of my 9th grade science class.
Oh, my God.
And I could not go back over it with you now. Like, it was a memorization quiz. And once I no longer needed it, I discarded it. Like,
so I guess there would be a lot of sort of under definitions. You would have like moon planets and perhaps dwarf planets, classical planets, gas giants, ice giants, terrestrial.
I think you would absolutely have to define them separately. You can say they're all planets, but you would have to define them to make sense of them. You know, it's like, even on like the periodic table, I hate to go back to that, but you know, there's a portion of it that, you know, especially as of late, because the periodic table has exploded in length.
Yeah.
That they're like, okay, these are nuclear elements. They disappear as soon as they show up. You really don't need to know anything about them. They show up, they disappear. Like, we only see these inside of the collider.
Yeah.
So, I mean, sure, there would be a portion, you know, the rock portion, as it were, you know, the tiny thing portion, where we go, yeah, those are there, but you really don't need to learn these. And why would you want to?
Of course, it would like put more emphasis on the big moons because they are planets. So you would talk about like the X number of planet moons for Jupiter and then the tiny moons.
Yeah, absolutely. I mean, and the giant moons, it's kind of weird because if you think of Jupiter as a tiny star, because compositionally it kind of sort of is, it just never underwent fusion, like it's made of the same crap.
Yeah.
It just wasn't big enough to, you know, collapse. So you can almost say, well, you know, like Europa, is that the big one out there, or Triton?
Ganymede is the biggest one.
Okay, so Ganymede. You have Ganymede out there, which, I mean, no one who looks at Ganymede can say that's not a planet.
It has bigger diameter than Mercury.
I mean, you can't look at that thing and go, yeah, that's not a planet because it goes around this other thing. No, that's a planet. That is a world. Like, you can land on it, you know, you can colonize. That is a world. The University of Hawaii has already kind of adopted this.
Yeah, and of course the IAU doesn't really have, so it has only the authority that you give it. So if this becomes a commonly accepted definition, then it becomes the definition, and the IAU just has to give into it.
I mean, it's like that with pretty much any body of power. It has as much power as you give it. So.
Yes, I think the IAU has done a really bad job of dwarf planets, because they acknowledge 5 things as dwarf planets, but we have a lot of dwarf planet candidates, and the question has not been addressed properly since 2006.
Right.
Because, as I said, there are 3 objects clearly round, bigger than Ceres, and if nothing else, they should be dwarf planets. My great idol, Mike Brown, he claims that we probably have 300 dwarf planets in the solar system, but most of them haven't been detected yet. He also reflected on this proposal, and he was pretty skeptical, I must say.
So let's go to the stupid question. Do you like this proposal, and would you accept this proposal? I'm a yes. I'm a solid yes.
I am a solid no, I think. I think it's way too confusing.
I think it makes it simpler.
I think it makes it more complicated.
If it's round and it's not on fire, it's a planet. Like, how can you make it any simpler than that? Like, now we're going through all kinds of complications where we're saying, yes, well, I mean, the ridges on that thing makes it not quite round, so that does not get to be a dwarf planet. And it's like, what? Shut up. Okay, and that thing, it doesn't orbit our sun, so it's not a planet. It's something else.
It's great that they added a definition of what round is. The triaxial ellipsoid.
Yeah, I mean, having that, you know, so it doesn't have to be perfectly round. It could be oddly round.
I think this requires more discussion, definitely, because there are some strength in this proposal and some strength in the old one, but both are kind of flawed.
I think we're going to find flaws in anything. I think this one, on a teaching level, I think this one is simpler to teach to a child. Like, I had probably an hour conversation with my son today about this before me and you ever talked about this.
How old is he?
He is 16. He'll be 16 this year.
Yeah.
And he had a lot of questions about it. He's a very inquisitive kid. And, he had a lot of questions about it, which I wish I could repeat them or remember all of them. But we had a long conversation about this, and it does make sense that it's a lot easier to teach to in a rudimentary science class to kids who, for the life of them, I know we all want our kids to be doctors and lawyers, but there's some kids you look at and go, yeah, he's going to turn a wrench for the rest of his life. And there's nothing wrong with that. It's a great profession, but these people are not astrophysicists. Plain and simple. They're never going to be. So, and they're not going to be like Supreme Court judges or anything. These are just, your average kids. So on that rudimentary level, to just tell somebody, if it's round-ish, and it's in space, it gets to be a planet. That's a very quick definition that you can teach to any child. And they'll go, got it. And then if you want to go more in depth, you have the ability to do that.
Yeah.
You see where I'm saying? I think that's where its strength lies in my eyes as a proposal, where the old one, kind of confusing to try to explain, because he's like, well, what's the current definition? And I explained the current definition to my son, and he's like, so let me get this straight. And he brought up the whole, so if Pluto clears out its path in 1 billion years, does Pluto get to be a planet? And I'm like, well, I don't know if it's going to, but yes. Technically, by the current definition, you're right.
A great strength of this new definition, of course, is that it applies to other solar systems.
Yes, and rogue planets as well. We can't forget about these things. They are out there.
I like to go on a tangent that I've been thinking about.
He says hi, by the way.
Oh, hi.
And
hi from the listeners.
No, Tangent specifically said hi to you.
Oh, okay. So I looked into exomoons because I was like, wow, surely we can discover some exomoon. And there's a lot of thought going into that. And we have some exomoon candidates, but we have a problem with the definition of an exoplanet because there are some objects called sub-brown dwarfs. Do you know what a sub-brown dwarf is?
Not off the top of my head perfectly.
I have an
idea what it is, but...
Yes, because to be a brown dwarf and have some fusion in you, you have to be 13 Jupiter masses. Yes. So you have to be a lot bigger than Jupiter, mass-wise. But they have found things that have formed like stars. So you have this proto-cloud of a solar system, and it forms into a star-like object. But the whole cloud was way too small. So it forms into a Jupiter-sized object.
But maybe it's only 10 masses?
Oh, maybe it's 1. Maybe it's Jupiter forming out there in space without a star. And when we look at these objects, it's much easier to detect stuff orbiting them. So we have found 5 exomoon candidates because they are orbiting these sub-brown dwarfs. But then you run into the problem, what is a sub-brown dwarf? Is it a rogue planet? Because it formed in the way a star forms.
But it never reaches nuclear fusion, which...
No.
I think that is a key we must have for us to call it a star.
So, but that's another problem with the planet definition, because, especially with the old one then, because you orbit a star. And then, yeah.
I personally would
call these
that...
exomoons, I just have to explain, but they are all Earth-sized, pretty much.
Okay.
And that's like, okay, but they feel like planets orbiting a failed star. But they are then, if you count it as a rogue planet, they are indeed moons. Exomoons. Moons in another system.
So...
But if you count it as a you see the problem.
Yeah, I'm trying to think of this. So what you're saying is we could have rogue planet solar systems.
Yes, and we do. We have a pretty good indications of one with 3 Earth-sized objects orbiting it.
Huh.
And I think it's like, now I don't remember. It might be 7 Jupiter sizes. It's never undergone nuclear fusion. What is it? Is it a star or a planet?
If it's never reached fusion, I can't call it a star, so I would call it a rogue planet.
Well, then we have exomoons now.
Then yes, I would agree with that statement.
But it's a topic of discussion among astronomers. So it's definitely not clear yet.
I can see why. Because I can see both sides of the merit. Because you're like, well, a whole system formed around this thing, that's its star. Its gravitation, alone is going to create a type of heat. Not like we're used to where it's, ray heat. It's more of a gravitational heat, but it does create a heat. So
if anyone knows more about the IAU, I would like to know more because I feel that they are not doing their job. If their job is getting definitions done, maybe it's a very hard organization to get to do this stuff, but why are dwarf planets not being nominated as dwarf planets, and why don't we have proper definitions for stuff like this?
See, I'm going to assume, and this is a complete assumption, so
yes.
I'm going to say that the IAU has too many people in it.
Yeah, that's probably.
And when you get too many people.
And too many opinions.
Yeah, too many opinions. People start to fall into cliques. And nothing ever gets agreed on. That's why a lot of governments that you see that are smaller tend to work better. Where the big ones turn into shit shows.
Yeah, we can see this in many scientific debates in history as well, that some questions that are hard, like these planets, what's a planet? The discussion tends to go on until the original people die. And then new people can sort of take new positions and think about it logically, but people get so entrenched in their opinions. So, it could go on for 40 years, worst case.
How do you feel about it? Because I personally would say that it's a rogue planet with its own system around.
Yeah, it's,
would you call them stars?
That's a valid opinion, but I can see the other opinion as well. I don't think my opinion matters very much there, but,
I'm sure the listeners want to know. I'm going to say the listeners want to know what your opinion is.
Okay, then I'm going to go for failed star and not planet, so we can oppose each other.
Okay, why not? I'm right because I'm American. And we do everything right.
But then, of course, how do you track the origin of a rogue planet? So is it a gas giant that has been thrown out of a star system, or did it form on its own? How do you tell that?
See, now that's where the real question is.
Yes.
See, that right there is where it goes, oh, wait a second, because a rogue planet does not form from a nebula, and it can be a terrestrial planet as well. It's just a planet that does not have a parent star.
Yeah.
The current belief is most of those were just thrown out of other solar systems by, Jupiter-sized objects or whatnot. But I don't think that there is a solid definition that says that a rogue planet must form that way. I mean, the common perception is that they've been thrown out, but that doesn't mean that they had to form that way. In my eyes, I think that, there was a nebula there and it just never ignited.
And then I think we run into another problem, and now we're getting pretty deep when we get to the brown dwarfs, and we'll talk about brown dwarfs in their own episode. But if you are a size 12.5 Jupiter mass object, and you have a certain composition of materials in you, you could probably have brief nuclear fusion. And maybe you had that 2 billion years ago, and that would be hard for us to detect. So are you then a star?
I think what you do is, as you're detecting it, you take the known parameters, you apply it to current definition, and you make your decision from there. And as parameters change, your opinion should change with it. Like if we don't know that it is ever ignited, it's a rogue planet. If we don't know. But as new data comes in, if we learn that, hey, at one time this thing did ignite, then we go, oh no, that is a star or a former star. It's the remnants of a star, whatever you want to say. I think that you can only work with the definitions you're given at the moment and the data you're giving at the moment. You can't, while theoretically it creates a really cool place for us to chat about it, at some point you have to apply the tools that you have.
And it's, of course, a great prelude to our next episode, which will be Jupiter Part 1.
Yeah, I have no clue how many parts this is going to be. I just know it's going to be more than one.
Yeah, because Jupiter has a lot of qualities that stars and brown dwarfs do have, but it has never been close to nuclear fusion.
We could probably do an episode on the storm alone.
Yes.
Then we can do an episode on Jupiter as a whole. Then we can do an episode on like the 4 big moons. Then we can do an entire episode on the rest of the moons. Then we can do
field.
Yeah, and then we can do an episode
the Trojans.
on the 80 Trojans that are out there. Like, I mean, Jupiter's got a lot going on, so I'm assuming this one's going to be a few parts. We may actually even walk away from Jupiter and come back later, just so we can get through the solar system at a decent pace.
This year.
Yeah, because, I mean, we could do Jupiter for the rest of the year.
Yes.
Theoretically.
I will start next time.
We will start and we'll, move to that. But before we do that, we have iTunes, Facebook, Google Play, YouTube. Please go to all those places, download our show, hit those like buttons because most of them have like buttons. Comment, leave iTunes reviews, all that good old stuff. Please do that. I enjoy that. We got a tweet this week from somebody who liked the show.
Oh, thank you.
Yes, I thought I should tell you that. And we'll even take the tweets. Where you can find our official Twitter at where, Dan?
Oh, FOA Angelo.
Yeah, that's it. FOA Angelo. And we did receive a very nice tweet from a Goddess Soul Plattle, or Soup Ladle. Sorry. When you don't separate words, it's hard to read the first time. But she says she loves the show and she couldn't wait for this episode, and I appreciate that. I'm assuming it's a she. I'm probably wrong.
You can also reach me on Twitter at Dan Horning, and I love to talk some astronomy as well.
Yeah, you can get a hold of me directly at Gonksuo on Twitter. That's GANKSUOU. And you can get both of us on the Facebook page.
Yeah, it's just Fan of Astronomy. Just search for it. And
2 posts every day. New stuff.
YouTube, Fan of Astronomy. All of the episodes and some bonus material.
Yes.
I just uploaded, I visited another planet in the Sweden solar system model. That happened since last episode.
What?
We do have the Globe Arena in Stockholm. It's a gigantic spheroidal arena. And when it was built in 1990, they constructed a solar system model on scale with the arena because Sweden is pretty long. And the model is the size of the country.
Okay.
So I'm looking down at Neptune. It stands in a park here in Söderhamn. We're about 220 kilometers from the arena. And it's to scale. It's 1 to 20 million. And last week I found Mars standing in a shopping center being about the size of, I'm trying to find the American term. That's basketball. It's slightly smaller than a basketball.
Okay.
So like a soccer ball.
All right. So how big is your sun?
The sun is an arena that seats 10,000 people.
Okay.
So I don't know the measurements. I actually done a video with the arena, but I haven't edited it. But I have videos in a playlist on Fan of Astronomy of me visiting Pluto, Neptune, and Mars.
Okay, I'm dying to know. How big is Pluto? Like golf ball?
Charon is like a golf ball, and Pluto is somewhat larger.
Like a baseball, okay.
And they are in a park in a very small village called Delsbo. So it's a big stone monument, and then it's sort of has a hole in it where you can look at Pluto and Charon so that you can't steal them.
It would be awesome if you guys would put those on rails.
And actually, Earth has been stolen several times.
Awesome. Because if you put them on rails,
old, university, and people steal it. It's been stolen like 3 times.
So if you put it on rails, that's kind of like the cow head around here. I'll explain that at a different time. Anyway.
But Neptune is quite impressive. It's like 2.5 meters, like 8 feet across. And it's, they light it, during night. And there is a bar where you can sit and be at, Triton. If you're sitting in the bar, you are Triton, looking at Neptune.
So, I'm sorry. I'm just thinking, I can't get the thought out of my head that if these things were on tracks of some sort, you could put them in orbit and show.
Yeah, they would end up in Russia though, so that's not a good idea.
Putin will be okay with it.
And you have like the heliosphere is the national border to the north.
That is
so
awesome.
Of course Mercury, Venus, Earth and Mars are all in Stockholm. So it's a solid walk between those four, which I haven't done yet.
Why not?
So that's, if we get really big, I'll arrange a walk in Stockholm for the listeners.
Yeah, if we get really big, I'm going to Sweden.
Yeah, and we can have a party.
And we are going to film us doing this.
We're having a pretty good observatory here, an IMAX theater with astronomical stuff in it as well, so we could create a whole week full of events.
Yeah, we would absolutely do that if we got big enough. We'd invite fans and everything. That'd be amazing. I want to do this now.
Yeah, that's fantastic.
Yeah. So again, that was our contact info. If you wanted to get a hold of me, as I said, Gonksuo on Twitter, I do that. That's my personal one. We have the Facebook thing. Dan said his. And next week we're going to go over Jupiter again. I mean, we're going to miss a lot of stuff. I'm going to apologize right ahead of that because there's just too much. So
yes, this gigantic monster hanging out in our solar system.
We will come back to it in the future, I promise.
Yeah, we're still learning a lot about Jupiter.
So if you say, hey, you guys barely talked about this part of Jupiter, I'm going to say, yeah, we know. But Triton alone can be its own episode. So we're going to have to glaze over a lot of this, unfortunately. But we'll try to keep it as entertaining as we can and still useful.
Yeah.
Yeah. So if you like this show, please do me a favor, tell a friend. If you didn't like this show, still tell a friend.
Yeah, give the show to your friends and enemies.
Yeah, please, word of mouth would be great. Let people know about us. We will talk to you guys in 2 weeks when we start on our Jupiter thing. But until then, I thank you all for listening and wish that you come back. And also, please continue to look up at the stars. We learn something new literally every day.
And maybe you'll spot an asteroid. If you do, you get to name it. That's still going on.
It will always surprise.
What'd you think? Did you enjoy it? Well, if you did, head on over to patreon.com/astronomy and pledge to these guys. For each patron they receive, the more they will be incentivized to improve the show. So help them out so they can help you out and throw them a couple bucks an episode. They will really appreciate it. Thanks.